Cool.
Good evening, everyone.
Mm-hmm.
My name is Nicole, and I will be presenting a research topic about acid mine drainage in South Africa. So, as we all know, coal is a key energy resource that can be used for many energy purposes, development, and economic prosperity. It accounts for 28.9% of the world's energy consumption, and particularly in South Africa, it meets 77% of its energy needs, making it a vital resource and important resource for South Africa. Though coal is an important resource, one of the major drawbacks I'll be focusing on again is acid mine drainage. Now, acid mine drainage is mainly caused when abandoned coal mines as well as active coal mines come together and they don't utilize the waste products well, and it ends up running into water. Acid mine drainage is especially harmful because it can occur indefinitely, especially after mining has long ended. Since South Africa has relatively little water compared to that of the world, to be precise, 464 millimeters to 890 millimeters, quality is especially important for its people. It's my goal to provide you with further insight into the disadvantages of coal mines in South Africa on its water systems as well as its biodiversity, specifically pertaining to acid mine drainage. So, as I previously stated, coal mining in South Africa is a main resource of fuel. According to WWF, or the Worldwide Fund for Nature, coal currently accounts for 92% of South Africa's generated electricity. Now, I had the chance of witnessing acid mine drainage myself while visiting Africa. As we drove down the rugged roads towards the Segela River, our safari vehicle made a halt at this cleavage in the hillside that resembled a dry river basin, but once we took a step out and took a step further, another picture was painted. Our tour guide then explained how the copper-colored layer that you could see in the soil was formed by oxygen and metals that came together, which created the rust color. Eventually, that led to acid mine drainage without the water basin, which eventually led to the water basin being dried out because as acid mine drainage occurs, all of the oxygen and everything is stripped, and other resources are stripped from the water, leading it to dry out. Now, as again, acid mine drainage occurs when sulfide comes into contact with oxygen and water, then oxidizes to form sulfuric acid as well as iron. And like I said, it leaches other metals from the river, leading to a decline in overall pH, as well as a decline in overall biodiversity because it robs fish and other macro and microinvertebrates of the oxygen that they can breathe. Now, acid mine drainage can occur mostly. It can occur mostly. It can start mostly in little streams, and can happen by several different ways. First, the streams can be impacted when contaminated groundwater interacts with them. Secondly, that water can be incepted and stored in mining soils, which gradually be released by seepage and then eventually draining into the streams. And lastly, those stored water can be released intermittently when the impoundment and the storage of when the impoundment and the storage reaches its capacity, such as a rain event, and then also leads into the rivers. Now, water quality is not the only subject, as I said, that's affected by acid mine drainage. Biodiversity become a casualty as well. Plants, animal, and human lives are affected greatly by acid mine drainage. Again, according to WWF, the acidification of water, especially those that are 4.2 pH and below, have severe impacts on aquatic ecosystems. Due to the quick change in pH and the high metal concentrations, plants become unable to produce the oxygen that's needed for survival, and because the plants depend on the biocarbonates as an inorganic carbon source, and if the acidification limits and destroys their ability to photosynthesize, that leads to their death. When plants are unable to photosynthesize, they don't provide materials necessary to keep sufficient water quality, and therefore the water and Therefore, the water and biodiversity suffer greatly. Now, treatment of acid mine drainage will be a tedious task. There are chemicals that can be used to treat acid mine drainage, which include limestone, lime, soda ash, pebble, and quicklime. Each chemical has characteristics that makes it more or less appropriate for the specific treatments, but the best choice depends on both the technical and economic factors. The technical factors include acidity levels, flow, and the type of concentration of metals in the water. The economic factors include the price of the reagents, the labor, machinery, and equipment, and the number of years the treatment will be needed, and as well as the interest rate. Now, in conclusion, acid mine drainage not only has economic effects, but as well as environmental effects as well. And South Africa's annual budget is already limited for such a large contact, but there are small hopes that the problem can be fixed. For instance, alternative sources of energy such as wind, solar power, as well as other fossil fuel resources are being looked into to get rid of coal and to reduce the amount of factories and other things being built, which will in time reduce acid mine drainage. Although this is not an issue that can be fixed overnight, with the correct guidance, laws, and regulations, as well as maintaining all of our coal mines, there can be a brighter outlook on the future to coal mining and acid drainage. All too often by time, effects of pollution can be seen. The consequences are already irreconcilable. We, as the voice of the future, need to truly recognize and realize the seriousness of this issue if we are to control and eradicate it.